everyone, I'm the Babywearing Math Teacher, and today we're going to talk about functions. This will be the first video in our function series. So the first thing we want to consider is, well, what's a function and how do I test to see if it's a function? So a function is going to represent bivariate data. Bi meaning two and variate meaning variable. So it's going to show the relationship between our variables x and y. X and y being coordinates on a grid, a graph. Alright, for every input there is exactly one output. It will pass the vertical line test. The inputs do not repeat, however the outputs can. The y values are allowed to repeat. Alright, so let's look at this. Functions can be represented in four main ways that you're going to see. You're going to see functions represented as equations, as graphs, tables of values, and word problems. So let's look at each of those individually and figure out how do we test if each of those is a function. So the first thing you might see is an equation. Equations, what we're going to talk about today is just in slope-intercept form. There are other forms that the equations can show up as, but for right now, we're just going to look at slope-intercept form. So slope-intercept form is the format y equals mx plus b, where m is your slope and b is going to be your y-intercept. So the y-intercept is meaning where it crosses the y-axis. So if we have an example equation, maybe y equals 1/2 x plus 2. You might be wondering, well, is that a function? I'm not really sure. Well, the way that you would test this, the easiest way I think, is to just graph it. So if you want to graph this, you first make a t-chart with your x and y values. I don't feel like this color is showing up very well. Let's switch. So you're going to have your t-chart with x and y, and for x you can pick any input you want. So I like to pick some pretty simple ones. I pick a negative value, I always pick 0, and I pick a positive value. Alright, so you know what? I should choose even numbers, and I'll tell you why. If I'm multiplying it by a half, it's much easier to take half of an even number. So I'll choose -2 and +2. Alright, so first I'm going to plug in this first value for x in my equation. So I'm going to say, alright, 1/2 times -2 plus 2 gives me what for my output? Well, half of -2 is -1. -1 plus 2 is +1. If I plug in a 0 for x, that means I'm multiplying 1/2 times 0, which gives me 0, and plus 2. Then I'm going to multiply 1/2 by 2. Half of 2 is 1, and 1 plus 2 is 3. So now I want to make sure that I did this correctly by graphing it. So I make my x and y axis, x and y, and give me some little tick marks, and then I graph it, -2, 1. So each of these are ordered pairs. We've all seen ordered pairs before, and we graph them on a coordinate plane. So back 2 and up 1, 0, 2, I go over 0 and up 2, and 2, 3. So over 2 and up 3. Then I connect my dots extending through, and I look at this. Does this pass, well, what we're going to talk about next, what's called the vertical line test. So let's move right into this. So if you have an equation, you want to graph it. If you have a line on a graph, you want to use what's called the vertical line test. The vertical line test says that wherever on this line, if I were to draw a vertical line, I'll use a different color to show you. So if I decide to draw a vertical line here, then that vertical line should only cross my function, or my line, at one point. And sure enough, it does. Even if I drew the vertical line over here, it would only cross it at one point. So that means that this equation and this graph are both representing functions. Actually, so is this t-chart, this table of values. All three of those are representing a function. Not only that, here's a little sneak preview, it's representing a linear function, meaning that my graph represents a straight line. Alright, last example, we've kind of touched on all three. So we've covered equation. If it's an equation, you want to graph it. If it's a graph, you want to use the vertical line test. If it's a table of values, again, graph it and do your vertical line test. In the table of values, if you're looking at all your x values, this -2 should never repeat unless it were to have the exact same output. Over here, You can basically have any combo of numbers. If the y's repeat, it's okay because a horizontal line would be a function. Alright, so now we've looked at all three of these. Let's move on to a word problem. I have brought a handy-dandy word problem with me. I hope you can see it, but I'll read it out loud just in case. Alright, so the lemonade stand made $3 its first day of business and averages a profit of $5 a day since opening day. What is its projected gross income after 20 days of business? So if you have a word problem, the first thing you want to do is try and convert it into an equation and see if it's in slope-intercept form. Alright, so if you look at this, first thing you want to figure out is, well, what's my slope? What's the rate of change? Is it $3? Is it $5? Or is it $20? Well, the slope is going to be happening over and over and over again. So on the first day it made $3. Are they making that every single time? No. Are they making $5 every time? Yeah, so $5, this is going to be my slope. So in my equation, y equals mx plus b, I've identified m. M in this instance is 5. Alright, the next thing I want to try and figure out is my y-intercept. The y-intercept I like to think of as the starting point. This happens once, and from there we're moving up and down. So that's either the 20 or the $3. Well, usually your slope and your y-intercept are going to be in the same format, so money on both of those numbers is going to be my first clue. So if we're starting at $3 and increasing 5 a day, then that probably is going to be my y-intercept. So now I've identified b, which is 3. So now I have an equation in slope-intercept form. Y equals 5x plus 3. So from here, I should be able to plug in the 20 days, depending on which variable it is, and if I plug it in for the correct variable, I'll get my output, which means how much money they made. So if you look at this equation, if they are in business 1 day after opening day, then I would just multiply 5 times 1 and add it to 3. So in this case, I'm looking for 20 days. So I want to replace x with 20. I multiply 5 times 20, which is 100, and add that to 3, and I get a total of $103. So the way I can tell that this is a function is I can just graph it. Okay. So if I think of my inputs, on 0 days, on opening day, they made $3, so that's my first point. On 1 day, they would made the $3 plus an additional $5, meaning the output's going to be at 8. 1, 2, 3, 4, 5, 6, 7, 8. So after 2 days, we're going to be 5 higher, and this line is going to be a nice steep line going up. Now obviously my line is not perfect because I am not a computer, but if you're sketching it out, then that'll do. So those are 4 different ways that we can represent a function, and ways that we can test and figure out if each representation truly does represent a function. Now, this is our first video in the function series, so be sure to stay tuned for future videos. I'm the Babywearing Math Teacher because math is so good.